Hello, welcome back to my channel. Today, let's get back to some actual math. So I'm excited for that. I hope you are too. We have been uploading a few kind of like daily life vlog sort of videos in the last few. I did one on productivity. I did one yesterday about what is the goal of your channel. And today I want to actually show some math again. So let's work a problem together from Bishop from PRML, which is a book that a friend recommended for me to learn probability from. Probability and machine learning, because a goal of this whole channel is that I want to learn the math that's relevant to machine learning. Primarily for fun, just because I love learning math, and I just want to learn it for myself, because I think it's amazing that we can make ChatGPT answer our questions at 2 in the morning, and we have an infinitely patient tutor available at 2 in the morning. But then secondly, I'd like to teach others. I want to tutor, so if anybody wants a private tutor, hit me up. Thirdly, maybe I want to go get a job in machine learning, but that's a third priority, really. So let's get the iPad up on screen. Where are we? How does this go? How does this work again? This one? Oh no, that didn't work. All right, so first we need to do that, and then, all right, then we need to do that, and now things should be looking a little bit better. All right, so PRML exercises. I found my Apple Pencil again, so this is fantastic. PRML exercises. Right now we're working on probability theory. Something I did that I realized yesterday is with this fantastic app Notability, you can just like copy paste specific parts of a PDF. First off, you can just show a PDF in dark mode. That's really cool. And then you can like kind of cut and paste individual problem statements. So we have 1.3, and I want to show that one to you all. So let's work this one together. All right, take 2. I completely flubbed the last one. A lot of little dead ends. So let's just refilm this whole part. Here is this problem from Bishop. I can't believe I messed up a simple probability problem, but that's going to happen all the time. So suppose that we have 3 colored boxes, red, blue, and green. Okay, so we have a red box, we have a blue box, and we have a green box. When I'm solving math problems, I like to draw pictures. I think that helps pretty much everybody. Box R contains 3 apples, oranges, 4 oranges, and 3 limes. So what I'm going to do is I'm going to remind myself, always list apples, oranges, limes in that order. Apples, oranges, limes. So I'm just going to write that somewhere so that I don't forget and I don't get confused and I don't have to refilm a video. And then we have box B contains, so red has 3, 4, 3, which maybe I like to draw them here. 3, 4, 3. Box B has 1, 1, 0, and box G has 3, 3, 4. Okay, so the question is, if you have a different likelihood of choosing the boxes, maybe for some reason your favorite color is green, and therefore you're more likely to pick the green box for some reason, or subconsciously, for whatever reason, the green box is more appealing. You have a 60% chance of reaching into that one and a 20% chance of reaching into the other ones. We have 2 questions in this problem. First, what is the probability of selecting an apple? Okay, so why don't we just focus on that first? what is the probability of selecting an apple? P of, remember I introduced the little term A earlier. Okay, the probability of selecting an apple. There are 3 different ways you can choose an apple. So if we can calculate the probability for each of those, multiplied by the probability that those cases happened in the first place, then that is basically what we're using is the sum rule, or the sum and product rule together, I think. I don't know. The sum rule, really. What this is going to be is the probability of selecting an apple from box 1 times the probability of choosing box 1, and then the probability of selecting an apple from box 2, which is blue, times the probability of choosing box 2, and then the same for box 3, which is green. Okay, so now the probability of choosing an apple from the red box. Well, first, this part is easier to calculate. P of R, P of B, and P of G, we've already written down in blue earlier. So I'm going to go ahead and write down, these are just reminding ourselves 0.2, 0.2, and 0.6. Let's do it like that. Now, the chances of choosing an apple if you reached into the red box. There are 3 apples in the red box, and there are 10 fruits in total, right? So, because of that, then we have 3 out of 10 multiplied by 0.2, which I'm going to write as 2 out of 10. Then we have, we do the same thing for the others. Choosing an apple from the blue box is 1/2, and then the chances of choosing the blue box is 2/10. And then choosing an apple from the green box is 3 out of 10, and chances that you choose the green box are 6 out of 10. So now we just multiply. We have 6 out of 100. We have 1/10, which is the same as 10 out of 100. And we have 18 out of 100. Adding those together, 16 plus 18 is mental math trick for y'all. Add 20, subtract 2. So 16, 36, 34. 34 out of 100. And another way to write that is just 34%. Or 0.34. All of these are correct, and just different ways to write it. Now here's the harder part where I stumbled earlier. The next question, let's hide a little bit of our work in progress. So we've already done this part. Let's say, next we say, if the fruit is an orange, then what is the probability that it came from the green box? So now it's different. We're not asking the probability of which a type of fruit. We're asking about the probability of the box that it came from. So if you close your eyes and spun around in a circle and you're dizzy and you keep your eyes closed and you reach into a box and then you pull out a fruit and you spin around again, I guess, and open your eyes and you see that it's an orange, which box did it come from? So this is kind of like asking a reverse question. Before we were looking at an apple from a box. Now we're looking at a box from given we're asking about a specific box, the green one, assuming that you chose an apple. So let's just remind ourselves, when you flip a variable in a probability calculation like this, that we can do by Bayes' theorem. And it's very easy to get backwards, so practice it a bunch. The second, so like if you, in this case, probability of y given x is like flipping those two variables. You can calculate the probability of x given y, which we did in the last part. We calculated that type of probability question. And I'm still learning probability for myself. Let's triple check and not restart this. Okay. How can I remember this? Because this is what I thought the first time, I think. So, yeah, p of x given y times p of y divided by p of x. It's really easy for me right now that I'm still practicing and learning this, to flip that p of y and that p of x. So, yeah, I don't know. Try to find a way that it sticks in your brain, like this y and this y are close together. Like you multiply p of y because, like, this one is y because it's close to this y. I don't know. Come up with something stupid like that. And it doesn't need to make actual sense, but that's going to help it stick in my brain, I think. So, rewriting this one. We did a problem just like this a moment ago. In this case, the other type of mistake that's easy to make. We're mixing up our box colors and our fruits and whatnot. So in this case, it's an orange, actually, is what the problem is asking about. And I remember I most recently wrote that G, so it goes right there too. Divided by P of O. Now, I'm going to let you see on your own. You can calculate that number is going to be 36%, and it's going to be just like how we calculated the probability of an apple. So try to figure that out on your own. And then the numerator, because right now the most important thing is that we are practicing Bayes' theorem. The numerator we will get from, let's duplicate this, because isn't that so cool? How cool is that we can do that? So the numerator, the probability of choosing an orange, which is the second, I believe. The probability of choosing an orange from the green box is 3/10. And then the probability of choosing the green box in the first place was 0.6. And now this is going to be 18 over 100 divided by 36 over 100. And we can see that that is 50%. Boom. Now you know about apples, oranges, and red and blue and Bayes' theorem. So thank you for watching. This was super fun. I think I only turned the timer one time this time. I have no idea how long this video is going to turn out. I have to do a tiny bit of editing, and that's okay. Math is full of mistakes, and that's part of the point of it all. So here we are practicing. I'm going to shift gears and practice math on my own. Actually, privately, I have to go. So that's nice. I get a opportunity to study math quietly by myself, which will be nice. And next time, I just want to give a little sneak peek. Next time, we're going to do something similar to this problem. And I want to try to give my own explanation of how many ways there are to shuffle a pack of cards. Yeah, so stay tuned. I think that'll be a fun video if I can actually get it done in time. That's what I wanted to do today, but I ran out of time. So thank you all for watching. All right, bye.